Hello. This is 45th question. That is, find the optimal path using an ant colony optimization algorithm for the below cost or distance matrix of a graph consisting of four different cities C1, C2, C3, C4 and two sales person S1 and S2 who want to travel through all cities in an optimal path. So we have to find the optimal path using an ant colony optimization algorithm for the below cost or distance matrix. In question paper, there is no cost or distance matrix mentioned, but yes, they're supposed to include this. Okay, this matrix must be included, but unexpected, maybe because of some unexpected thing, it is not included in the question bank. Okay, so we have to find an optimal path, and here we have four cities and two salesperson. We are considering two salesperson. Okay, like who wants to travel all cities in an optimal path. Okay, it's just like a traveling salesman problem. Okay, so this is a cost matrix given, and this as it is C1 C2, like C1 C2 C3 C4, and these are the cost with respect to that particular cities. Okay, so to be frank, I didn't find any of the solution regarding this. Okay, but now I'm sharing some of the related information which I received based on the topic, but even I'm not convinced with the answers which I have. Okay, if you can solve it, it will be well and good, but I tried my best to find an particular perfect answer for it, but I couldn't find the perfect answer. So now I'll share some of the thing which I got to know, and which was little bit related to this particular problem. Okay, so uh, okay, so we'll start now for the solution. That the first is ah, so this is just a graph from that cost matrix. I have drawn this graph. Okay, so this is a graph. Now since here we are considering two salesperson S1 and S2, like we are considering salesperson, so here S1 and S2 be the salesperson, and each of them will travel in different path. So let R1 and R2 be the routes or path. Okay, and if I plot it, it will be like this will be a R1 path and this will be a R2 path. Okay, this is a path. So now what I do is, now R1 has like S1 has traveled in one particular path and S2 has traveled in one particular path. Now based on this data, I will calculate the pheromone deposition, and there is two possibility in pheromone deposition, that is one either with evaporation and the other one is without evaporation. Okay, so first I'll take pheromone deposition without evaporation, that is we are not considering the evaporation here, only we are calculating the pheromone deposition amount. Okay, and this is a formula for it, where delta pheromone deposition of Ij. Here Ij means it is a path from one particular node to another. For example, C1 and C2 are two different nodes here, nodes or cities here. So I become C1 and J become C2. And K will be the salesperson. Like here there are two salesperson, that is S1 and S2. So here it will be either S1 or S2. So the pheromone deposition between I and J with respect to particular salesman, that is S1 or S2, any one of the salesman, will be like 1 by L of K. L of K means it's a cost of that particular salesperson, like total cost of that particular salesperson. Okay, so we'll understand with the problem how it will be used. Okay, once you calculate with one particular thing, like I and J is a city, and in that it's not only one particular salesperson will travel, there may be other salesperson use the same, that is like other ant, there may be other ant, that can also be traveled from I and J. So it will be like multiple deposition by ants. Okay. So the total deposition, pheromone deposition, will be the summation of all this thing. So this will be for one particular ant. There might be two or three. So when we summate all individual salesperson value, we'll get total pheromone deposited in that particular link. Okay. So we'll see now. We already know that R1 and R2 are two routes we are considering, and S1 and S2 are two salesperson we are considering. So, like there is like how many chance? There is a two routes and two salesperson. So, one particular salesperson choosing R1 or R2 will be like 50% probability. Okay, off of them. It will be like off of the probabilities. Okay, but now we'll assume that S1 is traveling in R1 and S2 is traveling in R2. Okay, so R1 is for S1 and R2 is for S2. So S2. Okay, so the salesman he got when he travel in a route R1, so he'll get total distance cost. It's actually a cost. Okay, it's not distance, cost. I can take it as a cost. Okay, so this is R1. So I'll sum it, since he start from C1, then he moved to C2, C3 and C4. Okay, or it may be like C4, C3, C2, C1. Okay, this is 1. So when we add up the cost, it will become a total distance cost. So it will be like 14. So 14 is a cost that is encountered by the S1. Whereas S2, when he chooses the route R2, the total distance will be the summation of that route. Okay, so it will be like 31. Okay, so the pheromone deposition in each, like, see, this total distance is the one which is calculated based on all the paths of the S1, like S1 traveled. Okay,